This is Mr. Martin, and we are continuing with Chapter 3. We're going to move into Section 3.4, and we've done a little bit with this already. We're just going to go into a little more depth in this section. So solving exponential and logarithmic equations. So a little review of some of our properties of exponents and logs. If I have a to the x is equal to a to the y, then x has to equal y. And this if and only if, this means that it goes both ways. So if a to the x equals a to the y, then x equals y, and we can read it the other way around. If x equals y, then a to the x is equal to a to the y. Alright, we have the same property here with the logs. Log base a of x is equal to log base a of y, if and only if x is equal to y. And here are our inverse properties. So a raised to the log base a of x is just x. And log base a of a to the x is equal to x as well. Alright, so let's go ahead and look at some examples here. So for this first example, if we're going to use our one-to-one property, we need to make sure we have the same base, because you'll notice here that these both have the same base of a. So what we need to do is we need to rewrite 64 in terms of 2. So I've got 2 to the x, and I know that 64 is 2 to the 6th, and now that they have the same base, I can simply see that x is equal to 6. Alright, moving on to part B, solving for x. Again, if we use our one-to-one property, I'm going to add natural log 5 to both sides. So I have natural log x is equal to natural log 5, and when we write it like this, we can see that x is equal to 5. Alright, moving on to part C. So in this case, we're going to use our inverse properties. So I'm going to take the natural log of both sides. So the natural log of e to the x is equal to the natural log of 8. Our inverse property tells us that the natural log and e cancel each other out. So on this side we're left with x is equal to natural log 8. So without a calculator, this answer is going to be sufficient. With a calculator, we would just plug that in and figure out what it is. Alright, for part D, again, in order to use our one-to-one property, we need to make sure that we have the same base. So I'm going to rewrite this 1/3 as 3 to the negative 1 raised to the x. And then I'm going to rewrite that 9 as 3 squared. So just a little bit of simplifying. 3 to the negative x is equal to 3 squared. So I know that negative x has to equal 2. Right, I'm just setting these exponents equal to each other, which means that x is equal to negative 2. Alright, so what is the purpose of using a logarithm? So basically, a logarithm answers the question how many of one number do we multiply to get another number? Alright, so for example, since 2 times 2 times 2 is equal to 8, the logarithm is 3. We have to multiply 3 2's to get 8. Alright, so if I wanted to write this in log form, we would write this as the log base 2 of 8 is equal to 3. How many 2's do I have to multiply together to get 8? All right. So suppose you cannot simply find the solution without a calculator. We can still solve using logarithms. All right, so let's take a look at some more examples. If you want to go ahead and try these on your own, feel free. Otherwise, we'll go through on the video. So for part A, again, we're going to take the natural log of both sides using our inverse property. Okay, so these the natural log and the e are inverses. They cancel each other out. So x is equal to natural log of 85, which we could plug into a calculator to get about 4.44. If it was non-calculator assessment, we just leave it as natural log 85. All right, now for part B, 6 times 3 to the x is equal to 51, so let's divide both sides by 6. So I get 3 to the x is equal to 51/6. Now at this point, we can basically use any kind of log that we want. So I'm going to use a natural log, and I'm going to use so I'll have natural log of 3 to the x is equal to natural log 51/6. All right, and then let's go ahead and move that exponent out to the front. So I have x natural log 3 is equal to natural log of 51/6. Divide both sides by natural log 3. And we get that x is equal to natural log 51/6 divided by natural log 3. This would be an exact answer. If we wanted an estimate, we just plug into our calculator to get about 1.95. All right, moving on to the next one. Solving for x. Again, when we're solving these, same process as solving for x always. We're trying to isolate x. So the first step is to subtract 5 from both sides. So I have negative 3 e to the x is equal to negative 3. I'll divide both sides by negative 3. So I have e to the x is equal to 1. So what do I have to raise e to get 1? That would be 0. Or you can take the natural log of both sides, and the natural log of 1 is still going to be 0. But the only exponent we can put in here, so that equals 1, is 0. All right, moving on to part D. I am going to subtract 4 and divide both sides by 6. So I have 2t to the t plus 5. So when I subtract 4, I'm going to get 7 and then divide by 6. So 7/6, just skipping a couple steps there. And at this point, again, I can use log base 10. I could use any log base that I want. I'm just going to use natural logs again. So I'm going to take the natural log of both sides. So the natural log of 2 to the t plus 5 is equal to the natural log of 7/6. Again, this exponent can come out to the front using our properties of logs. So I have t plus 5. Notice the parentheses there. Natural log 2 equals natural log of 7/6. And we'll divide both sides by the natural log of 2. So I have t plus 5 is equal to the natural log of 7/2 divided by the natural log of 2. Subtract 5 from both sides, and this will give us our exact answer. Natural log 7/2 divided by natural log 2 minus 5. And plugging into a calculator, we should get about negative 4.78. All right, so that's a few examples of solving some exponential equations. Let's move on to another solving equation, and this one's a little bit different. We're going to look at an algebraic solution and a graphical solution. So for the algebraic solution, we want to treat this like quadratic. So if we were to factor this, we would get e to the x as our first terms in each. Alright, so now we're looking for numbers that multiply to 12 but add to negative 7, so that's going to be negative 3 and negative 4. Alright, so the inner would be negative 3 e to the x, and the outer would be negative 4 e to the x, which would give us our negative 7. Negative 3 times negative 4 is 12. E to the x times e to the x is e to the 2x. Then we'll use our product property. So e to the x minus 3 is equal to 0. E to the x is equal to 3. We'll take the natural log of both sides, and e is equal to natural log 3, which is about 1.1. And then e to the x minus 4 is equal to 0. So e to the x is equal to 4. So exact answer, x is equal to natural log 4, taking the natural log of both sides, which is about 1.39. Now, if we're going to do this graphically, what we want to do is plug this into our y equals, and then we're going to graph it, and I'm going to spread these out. Here's 1, here's 2, and if you want to pause the video right now and go ahead and graph this, and then see if you can find the intercepts using your calc feature. The graph is going to look something like this, and it's going to cross the x-axis there, and then if you use the calc feature for your graph on your calculator, you'll get that this value of x is 1.1, and you'll get that this value of x is about 1.39. Okay, and if you have questions on how to do that, make sure that you check in with me. Alright, moving on to number 4, more solving logarithmic equations. So let's solve the following. And at any time, if you want to pause the video and work these out on your own and then just kind of fast forward through the solutions to double check your answers, feel free. Alright, so for this one, I'm going to make each of these an exponent with a base of e. So I have e raised to the natural log of x is equal to e to the 2/3. And the e and the natural log are inverses, so they cancel each other out. So x is equal to e to the 2/3. And we can leave our answer just like that. For the next one, again using our 1-to-1 property, if I have the log base 4 of this expression and the log base 4 of this expression and they're equal, that means that 3x plus 2 has to equal 6 minus x. We'll add x to both sides and subtract 2 from both sides, so I have 2x is equal to 4. Let's add x to both sides, so 4x is equal to 4, which means that x is equal to 1. Alright, moving on to part C. So we have all log base 3's, but I need to have a single expression on both sides. So I'm going to use my log properties to combine this into a single log. So I've got the log base 3 of 5x plus 13 over 6 is equal to the log base 3 of 3x. Now I can take these and set them equal to each other. So I have 5x plus 13 over 6 is equal to 3x. I'll cross multiply. 5x plus 13 is equal to 18x. Let's subtract 5x from both sides, so 13 is equal to 13x, which means that x is equal to 1. Alright, moving on. Again, we're trying to isolate x, so let's divide both sides by 3. Now, we could move that up to be an exponent, but it just seems easier if we divide both sides by 3 to start. So log base 4 of 6x is equal to 3. And let's use our log properties to rewrite this in exponential form. So 4 cubed is going to equal 6x. So we know that 4 cubed is 64, and x is going to be 64/6, which is 32 thirds. Alright, and moving on to the last part of this problem. Again, we want a single expression on both sides. So let's combine these. So I'm going to have the natural log of x minus 2 times 2x minus 3 equals, and I'm going to bring that exponent up, natural log of x squared. So now I have a natural log on both sides. So now we can set these equal to each other. And I'm going to distribute this. So I've got 2x squared, so I'm going to have minus 3 minus 4, so minus 7x plus 6 is equal to x squared. So we'll subtract x squared from both sides, so I get x squared minus 7x plus 6 is equal to 0. And let's go ahead and factor this. So I need two numbers that multiply to 6 and add to 7, so that would be 6 and 1. And they both have to be negative, which means that x is going to be 6 or x is going to be 1. Alright, so I'm going to end this video here. Remember, if you have questions, make sure you get those answered. And we will see you in the next video.